So the starter for today's lesson is I want you to find the volumes of these shapes by counting the cubes. Don't forget to include the hidden cubes, so the cubes that you can't actually see. So pause the video and have a go at that. Okay, so answers you can check how you got on. 18 centimetre cubed, 15 centimetre cubed. We mustn't forget that this one layer at the bottom must have 9 cubes in it, even the ones we can't see. 21 centimetre cubed, and this one here is 90 centimetre cubed. So that was quite a lot of cubes to count. So I'm sure you found a quicker way rather than counting all the individual cubes in that one. So let's have a look at that quicker way in just a minute. So it's pause, and can you write the title, volume, and today's date, which is the 24th of April, into your exercise books? Can you write the definition of volume down into your exercise book? So volume is a measure of the amount of space there is inside a 3D object. So we mustn't get volume muddled up with surface area. Surface area, remember, is the area of each surface added together, whereas volume is how much space there is inside something. So let's go back to this big cuboid and look at the quicker way of working out the number of cubes. So we can see that the volume of the cuboid would be the number of cubes in the first slice. So if we look at a slice as this first slice here, this 3 cubes along the bottom and 6 cubes high, the number of cubes in that slice multiplied by the number of slices. So that gives us 6 times 3 times 5, which basically means we've done length times width times height of the cuboid to get the volume of the cuboid, which was 90 centimetre cubed. So that's how we get our formula for volume of a cuboid, which is length times width times height. Now remember, it doesn't matter what order we multiply numbers in, so it doesn't really matter which of our dimensions on our cuboid we call length, which we call width, and which we call height. So you'll find this on your note sheet, and I'd like you to copy this example down. If you haven't printed the note sheets, draw yourself a quick sketch of the cuboid and put the example into your exercise book, and you definitely need to be writing down the volume of a cuboid formula, because this is something that you will need to learn. So if we wanted to find the volume of this cuboid, we'd simply multiply the 3 lengths, the 3 dimensions together. 3 times 2 times 5, it doesn't matter about the order. I've chosen this order, so if I multiply the first 2, it gives me 6, and then I times that by 5, I get 30, and the units of volume are centimetre cubed. So the total volume of the cuboid is 30 centimetre cubed. Okay, let's just have a look now at prisms and how we get the volume of a prism. Again, we've got a triangular prism, as we were working with yesterday with surface area. So in order to find the volume of the prism, we need to find the area of the cross section. Now the cross section of a prism is the triangle in this case, and we can determine a prism's cross section, because it might not be a triangle, by looking at what the front and back face are. And remember, we talked about yesterday, they're the 2 opposite faces that will be exactly the same size. So if we find the area of that triangle, we know that's base times perpendicular height divided by 2. Although this doesn't specifically say perpendicular height, it is the perpendicular height. We can see we've got 1, 2, 3, 4, 5 high. So the area of our cross section is 20 divided by 2, which is 10 centimetre squared. So that's like our first slice. Just like on our cuboid, the area of our first slice is 10 centimetre squared. And then what we need to do is we need to look at how many slices we have. Okay, so we've got 10 cubes in the first slice. So the total number of cubes, or the total volume, is the cross-sectional area times the number of slices, which is our length of 6 centimetres. So our total volume is 60 centimetre cubed. So what that does is it gives us a formula for the volume of a prism, which is the area of the cross section, so we can think of that as the front face shaded in here, times by the length, which means area of the first slice, area of the cross section times the number of slices times the length. So let's have a look at that in a few more shapes and make sure we can identify which is the cross section and which is the length. So this is a triangular prism because the cross section is a triangle. So there's the cross section of the triangle, and the length, or the number of slices, would be this here, which is 90. We're not going to go through and work all these out, we're just making sure we can identify the cross section and the length. So this second shape here, again, my cross section is a triangle, so I could work out the area of that triangle, and my length is 4 meters. I've got a different prism here. It's actually called a trapezoid prism. And we see it's got a trapezium at the front for its cross section. So we could work out the area of that trapezium, which we were doing a couple of lessons ago, and then we'd multiply it by the length, which is 7 centimeters. Moving on, again, we've got a different cross section here. This is a parallelogram. So we could work out the area of the parallelogram. Remember, that's just the base times the height, so the 10 times the 5, and then we'd multiply it by the length, which is 12. This one here, it's a bit more tricky to spot, but this is also a trapezium. It just so happens that the parallel sides are vertical instead of horizontal, so we'd get the area of that trapezium. There's our cross section, and there's our length, 3 centimeters. And a cylinder, again, we can see we've got a cross section here, which would be a circle, but instead of being at the front, it's at the top because we normally stand cylinders upright. So we could find the area of the circle, and the length would be the height of the cylinder, which is 30 centimeters. We're not actually going to be doing cylinders today because we haven't looked at how to find the area of circles yet, but the principle is the same. Okay, so let's write this example down into our exercise book. Make sure you've got the formula. So you should have the formula for volume of a cuboid, which is length times width times height, written down, and volume of a prism, which is area of cross section times length. Okay, so the way we're going to show our workings, we're going to write our area. I usually just write CS for cross section. That's what I mean by CS. So I can see that's a triangle, so it's 7 times 5, and I mustn't forget to halve it because it's a triangle. So I get 7 times 5, let's do this in stages, I get 35 divided by 2, and then if we do our 35 divided by 2, that's going to give us 17.5. So, and then to get the volume, I'm going to take the area of my cross section and I'm going to times it by my length, which is 8 centimeters. I take my 17.5 and I multiply by 8, and I get 140 centimetre cubed. I could put units of area here, centimetre squared, but it's fine just to put the final units at the end of the question, the units of volume, centimetre cubed. Okay, so now you're going to have a practice at questions. So I'd like you to have a go at either volume of cuboids, which you'll find in your My Maths textbook, or start on volume of prisms, the super challenge. So let's just jot that down. You can start on challenge or super challenge today, and today as well you can use a calculator. Okay, so start on the challenge or the super challenge. You can use a calculator. The super challenge you'll find on a sheet attached to the assignment or in the email, and again the hyper challenge, you need to go back to your textbook. Make sure you are finding the textbook answers and marking them.